Beginner Python, Credit Card Fraud Detection. Welcome. Today we will explore Python by working through a real-world problem, detecting credit card fraud. You will learn the basics of Python as we gently build skills toward working with actual data. Running the cell now. This comment describes our first step. It does not run as code. We are printing a friendly greeting. Print shows text on your screen. Running the cell now. Try changing the text inside the quotes. What new message can you show? What is fraud detection? Fraud detection means finding suspicious activities, like fake credit card purchases. We use data and Python to spot these problems early. Running the cell now. A comment helps explain the code. It starts with the hash symbol. This comment will also be skipped by Python. Let us store a number using a variable. Apple_count now means 3. We also set orange_count to 4. This print statement shows how many apples and oranges we have by using our variables. Running the cell now. See if you can add a new fruit and update the message. Now we are working with text. Text in programming is called a string. We store Eva's name as the variable owner_name. We print the owner and a message about the fruit. Running the cell now. Can you change the name to your own? Let us see how to get input from you. This code asks for your name. The input function lets you type a reply. Now we greet you using your imported name. Running the cell now. Try typing in different names to see what happens. Lists, storing many values. Lists help us store many items at once. For example, several numbers or names. We will use lists a lot in fraud detection. Running the cell now. We store 5 numbers in a list called transactions. Each number is an example of a money amount. This list could be from fake or real card purchases. The first item in a list is number 0. We use 0 to get the first value. -1 gives us the last item in the list. Running the cell now. Change the numbers or add a new amount. What happens? To visit each item, we use a loop. A loop lets Python repeat a block of code. For each amount in our transactions, the code inside will run. We print every transaction to see its amount. Running the cell now. Try adding a big number to see if it stands out. We are importing a special library to keep our notebook clean. The warnings library helps hide extra warning messages. Filter warning set to ignore means we will not see most warning texts. Running the cell now. This keeps things tidy as we use more libraries. We are using pandas, a library for handling data tables. This is the web address for a small credit card fraud data file. We load the data from the URL into a table called df. Now we print the shape, or size, of our data. It shows rows and columns. We show the first 5 rows as a preview. The preview lets us see what kind of columns and numbers we have. Running the cell now. Notice the amount and class columns. What other columns stand out? In this cell, we see how many of each class we have. Class column shows if a row is fraud or not fraud. Running the cell now. Is there much more not fraud than fraud? This is common. We want clear column names for beginners. Now fraud is our target column instead of class. Print shows the current columns in our data. Running the cell now. Renaming columns helps remind us what they mean. It is important to make sure our data is complete. ISNA with sum shows any missing values in each column. Running the cell now. Try removing a value to see how missing data appears. Let us pick just the fraud cases for a closer look. We select rows where fraud is 1, which means the transaction is a fraud. We print the number of detected frauds. Preview the first few fraud cases with amount and fraud columns. Running the cell now. What are the amounts in the fraud rows? Are they high or low? Many real fraud cases are larger than normal purchases. We add a new column called Suspicious. It marks true if amount is more than 200. Let us print the first 10 rows to see which are marked suspicious. Running the cell now. Change the amount in the code to test a new threshold. Let us add an alert system using a loop. We make an empty list to hold our alerts. Now we look at every amount in the table, one at a time. If the amount is more than 500, we mark this one as alert. Otherwise, we call it safe. This else block happens when the amount is not over 500. We add each alert to our alerts list. Finally, we make a new column called alert flag in our table. Print lets us see the first 10 transactions and their alert status. Running the cell now. Can you set a different alert limit and compare results? This cell shows us if fraud and normal amounts are different. We pick all fraudulent transactions and average the amount column. We do the same for non-fraud transactions. Now print each average with just 2 digits after the decimal. Comparing these numbers helps us build better detection rules. Running the cell now. Are fraud amounts higher? Think about why that might be. Mini project, spotting fake transactions. Let us try building a simple rule to find unusual transactions. We want to see which are likely to be fake. Running the cell now. First, we will get your own choice for where you think a transaction is suspicious. The input function asks you for a number. We turn the input into a floating point number for use in math. Now we add a new column to show which transactions pass your limit. Printing lets us preview which ones are marked as a user alert. Running the cell now. Try using 100, 300, or even 50 as your limit and see what changes. Now we look at only the transactions you flagged. We count how many were flagged by your chosen limit. Printing again shows a preview of these rows. This helps us review what our simple rule picked out. Running the cell now. Is this more or less than you expected? Before doing any kind of fraud detection, make sure your data is loaded. We check if the table is empty. If it is empty, print a warning message. If not, we are ready to move forward. This safety check helps prevent errors. Running the cell now. Practice, try removing the file loading code. What warning now appears? Let us see how to handle errors if things go wrong. Try is a way to attempt actions safely. Here, we try to get a row that might not even exist. If it fails, we catch the error and show what happened. This is important when working with real-world data. Running the cell now. Can you change the number to one that exists and see the difference? Recap. We explored lists, variables, data tables, and simple fraud flags. These are building blocks for deeper data science and fraud prevention. Running the cell now. Thank you for joining this beginner Python lesson. If you enjoyed this, like and subscribe for more fun projects. Now try making up your own suspicious transaction rules, and happy coding. Running the cell now. Challenge, can you come up with a better rule to catch more fraud?